Kepler's first law states that all planets move around the Sun in elliptical orbits, having the Sun at one of the focuses of the elliptical orbit. Now first understand the difference between an ellipse and a circle. In case of a circle, the distance from the circumference to the center always remains constant. The radius of the circle remains constant. But ellipse is actually a stretched circle in less technical terms. So instead of having one center, an ellipse contains two foci which are needed for defining and constructing that ellipse. Those two foci are present at the major axis of the ellipse. So Kepler's first law states that the planets move around the Sun in elliptical orbits in such a way that the Sun remains at one of the focus of the ellipse. In the year 1600, Kepler got a job with Tycho Brahe in Prague. His job was to use Tycho's data on Mars to fit with Tycho's cosmological model. When he ventured in doing this, he had to face a big problem. The problem was that Mercury, Venus, Jupiter and Saturn were easily fit in Tycho's model. But with Mars, the data of its motion in the sky was unexplained by Tycho's model. Kepler had to do a huge amount of brainstorming with Mars until he got a different idea. He went against the model and tried other conic sections as orbits of Mars. He only had circle and ellipse as their closed figures. The data easily became fit when the orbit of Mars around the Sun was regarded as an ellipse instead of a circle. When he tried this elliptical orbits with other planets, the complexities of his calculations became easier. Proof of Kepler's first law. Any planet with mass m is acted upon by a gravitational force F dash, which is directed towards the center of the Sun. Since F dash, the central gravitational force, is a central force, the angular momentum J dash of the planet with respect to the center of force is constant in magnitude and direction. That is, J is equal to R, J dash is equal to R dash cross P dash. R dash is the radius vector of the planet, that is the vector distance from the Sun and the planet. And P dash is the momentum of the linear momentum of the planet. P dash can be broken as mv dash, or mass of the planet multiplied by the velocity vector. So ultimately J dash, the angular momentum, equals to R cross mv, which is a constant. R is the radius vector, as I told, of the planet with respect to the Sun, and v dash is its velocity. M though is constant, m cannot change, mass of the planet cannot change. Since both R dash and v dash are always perpendicular to J, you can see that J is equal to R cross mv, cross product. So R and V are always perpendicular to J, the orbit of the planet. Think, the orbit of the planet therefore lies in a plane perpendicular to J. This is the direction of J will be determined by the screw rule, right hand screw rule. The direction of the velocity and direction of the radius vector, these two vectors will always remain perpendicular to J, as J is the cross product of R and V multiplied by M. This is at least a partial proof of Kepler's first law, which I am again repeating, that all planets move around the sun in elliptical orbits, having the sun at one of the foci.